Hello guys, welcome back again to our chase, okay, to the question Paurosi. All right, from the previous video I pointed out that the region I'm sorry. Okay, this board of mine is not stable. Do not know why. Okay, let me just resave it. Okay, it's fine. It's now a bit larger. It's okay. Now you have to resize it so that it is manageable. Okay. All right, from the previous video we said that the region that is the feasible region is where every combination there is going to lead us to a production mix where we are not going to exceed our constraints. Okay, we'll be producing within the demand, within the resources available. Okay, and we also pointed out that at point B, that's when we are going to have the optimum contribution. All right, that's where we are having the optimum contribution, and this whole region, the region A, B, C, D, and O, that's what we referred to as the feasible region. Okay, now a $1 million question is that what is this particular region? What are the coordinates of this particular region? What is the combination? Okay, how many units of standard chairs and executives are going to be produced on this particular region? So usually we have to come up with some legal mathematics. Okay, there is need for us to do some mathematics. So let us rewrite the equations of constraints. Let's start with that for materials. What was it? This 2s plus 4e is equal to 180. 2s plus 4e is equal to $80. 80 kgs. Then labor, we are having 5s plus 6e. 5s plus 6e it's equal to 180. All right, and I just have to label them. Equation 1 and equation 2. We are going to do a bit of some simultaneous equations, and in our high school, if you still remember, we did these things. Okay, we did these things. How do you go about it? Okay, there are several ways people might do these things, but I think my method, if you just use it, you're going to be a bit safer in your journey. All right, it's not going to be a bit hard for you. All right, I found out that this one could be the safest way of doing these simultaneous equations. All right, so let's say let's multiply equation 1. Multiply equation 1. Okay, by 2.5. Okay, or just let's simply say 2.5 by equation 1. So it becomes 5s plus 10e. Okay, 5s plus 10e, which is equal to 200. and we call this one equation 3, right? So equation 3 minus equation 2, we're going to have 4e is equal to 20, and e is equal to 5. All right. Now, if e is equal to 5, then what is equation 2? If e is equal to 5, equation 2 will become 5s plus 6 is equal to 180. So 5s is equal to 150. Okay, s is equal to 30. S is equal to 30. Just to recheck on your calculator to determine, let me just cross check as well on my calculator to determine if I obtained the computation correctly. Okay, I think I'm right on track, because 5s is put 150, yeah, that's 30. Okay, let's move on, because in the exam there won't be any time. So remember, you are guided with the objective function, and our objective function is c is equal to 6s. The objective function, let us go to this one. Where did you put the objective function? Yeah, 6s plus 9e. This 30 plus 9 e, we obtained it is e was found to be 5. Okay, so in this case we are having 180 plus 45, and we are going to get 225. Okay, so in terms of plotting, we are going to have the point is 530. Okay, the point B is at, this is 5e and 30. Okay, that's the fine B. But in terms of total contribution at this point, the total contribution at this point is 225, as we have discovered in our computations. Okay, that's the contribution we expect at that point. Okay, and remember, because it is the point where the materials and labor line meet, that's the optimum point, the optimum contribution point. Okay, if we produce 5 executive chairs and 30 standard chairs, we are going to achieve, okay, if we sell, okay, if we produce and sell 5 executive chairs and 30 standard chairs, we are going to achieve optimum contribution, or the highest contribution possible. Are we together? Thank you, ladies and gentlemen. We now have to consider a situation where we are faced with situations where we are faced with spare capacities, okay, where because of these limitations we are not going to operate to the maximum potential possible. We'll be having some spare capacity or slack. So there is also a question where which was requiring us to calculate the slack in this example Paurosi. So let us discuss that one in the next video. Thank you.